You're welcome to Immaculate Maths YouTube channel where I'm devoted in building students with zero tolerance for the fear of mathematics. In this video, I'll be walking you through the solution to the MAT 1 to 2 examination questions for 2018-2019 section. So for all year 1 students in University of Lagos preparing for your test or exam, this video is made just for you.
You see, you don't just learn by watching, you need to get your pen and paper and walk along with me. Now before I go ahead, help us to share this video to your class group chats. There are a lot of students out there that this is exactly what they just need for them to pass this course. Also, don't forget to subscribe to this channel if you haven't done that. So, without further ado, let's head over to our video for today. In this question, they said a function f is given by f of 1 over x plus 1 to be equals to 2x minus 12 for all real number x. Compute f of 2. Now, in this question, we want to compute f of 2. But we are given our f of 1 over x plus 1 to be equals to 2x minus 12. Here we are not given as a conventional like f of x equals to a particular value, but the idea is that we can actually, since we want to find f of 2, all right, so meaning that we can actually let 1 over x plus 1 to be equals to 2. Now on doing that, that means that we are going to have 1 to be equals to 2x plus 2. So if we make x the subject of formula, that means that we are going to have x to be equals to minus 1 over 2. Okay, because if you collect like times and you divide both sides by 2, we are going to have x to be equals to minus 1 over 2. All right, so now that implies that what? That implies that our f of 1 over minus 1 over 2, all right, plus 1, that is if we replace our x to be equals to minus 1 over 2 here, it's still the same thing as what? F of 2, which we are interested in. That is if I replace x to be minus 1 over 2, both inside the function here and outside the output here, what am I going to have? I'm going to have this to be what? 2 open brackets minus 1 over 2 minus 12. All right, so meaning that here we are going to have this to be what? Minus 13. So meaning that our f of 2 is what? Minus 13. So don't forget that we want to find f of 2. Now since we've gotten f of 2 to be what? Minus 13, so we need to find f of minus 13 because we are computing f of 2. All right, so here still the same idea. We let what? Our 1 over x plus 1 to be equals to minus 13. Again, we make x subject of formula. If we do that, that means we have minus 13x. That's by cross multiplying. Minus 13x, all right, minus 13 to be equals to what? 1. Collect like times, that means we have minus 13x to be equals to 14. That is if you add 13 to both sides. Then dividing both sides by minus 13, we're going to have x to be equals to here, that means we have this to be 14 over minus 13. All right, so we are not done, meaning that if we replace our x with what? With 14 over minus 13 here, all right, 14 over minus 14 over 13, all right, then plus 1. Okay, here it's still the same thing as what? F of what? Minus 13, because if you simplify what is inside this bracket, you are going to have this to be minus 13. So it's still the same thing as saying we want to substitute x to be what? Minus 14 over what? Over 13 on the right hand side of the equation. So here minus 2. And if we compute this with the help of our calculator, so here we have 2 open brackets minus 14 over 13, then multiplied by minus 12. So here we're going to have the result to be what? To be minus 184 over 13. So here we have this to be minus 184 over 13, and the correct answer to this question, or the correct option to this question, is what? Is option B. All right, so option B. So I hope you get the idea. So let's just move on to the next question. In this question, we have to evaluate the limit at which x tends to 2 of the square root of x minus square root of 2, all divided by x minus 2. Here we have this to be the limit at which x tends to 2 of the square root of x minus square root of 2, all divided by x minus 2. Now if you notice, by direct substitution, that is, if we substitute x directly here, we're going to have 0 divided by 0. So that means that we need to simplify our function. Okay, and how do we do that? We can actually rationalize the numerator. So if we do that, so what are we going to have? We're going to have this to be, that is, we are going to multiply the numerator by square root of x plus square root of 2, and also divide it by square root of x plus square root of 2. Here we have not done anything, because this will still give us 1. Okay, now if we do this, what are we going to have? That means we are going to have this to be the limit at which x tends to 2. So here, if we multiply this expression here with this expression here, what are we going to have? We are going to have this to be what? Now here, this is just difference of 2 squared. That is, if you have a minus b multiplied by a plus b. Okay, here you are going to have this to be what? A square minus b square. Alright, so if you apply the same principle here, that means that you are going to have this to be square root of x whole square, which is still the same thing as x. Then here we have square root of 2 whole square, which is still what? That's 2. That means you have x minus 2 divided by, here we are going to have this to be x minus 2 multiplied by square root of x plus square root of 2. Is that okay? So here you will see that x minus 2 will cancel x minus 2. Alright, so that means I'll be left with the limit at which x tends to 2 of what? Of 1 over square root of x plus square root of 2. And if you substitute 2 directly here, you're going to have this to be 1 over 2. So which is still the same thing as square root of 2 over 4, because root 2 times root 2 will give us 2, then 2 times 2 will give us 4. Okay, so another way in which you can go about this is to use a L'Hopital's rule. Since you know that by direct substitution you're having 0 divided by 0, that means we can conveniently apply our L'Hopital's rule. And how do we do that? Using L'Hopital's rule, that means we can differentiate the numerator and also the denominator with respect to x. And if you differentiate the numerator, here we have the dx of x square root of x minus square root of 2, all divided by the dx of x minus 2. Alright, so that means here we have this to be the limit at which x tends to of. Now if you differentiate square root of x, that means you are going to have this to be 1 over 2 root x divided by, that is, if you differentiate minus 2, the square root of minus square root of 2, you are going to have 0. So we have that. Then here at the denominator, if you differentiate x, that means you are going to have this to be 1. So that means here, if I substitute 2 directly now, what am I going to have? I'm going to have this to be what? 1 over 2 root 2. And here, if I rationalize the denominator, I'm going to have this to be root 2 over 4. So here we have the same results. Now that means the correct answer to this question is what? Square root of 2 over 4, which is the option D here. So let's move on to the next question. In this question, it said, for a given set of functions u and v, only one of the following is correct. Alright, so if you check the first option, we are given what? U v prime over uv. Alright, so what is your uv prime? If you should apply your product rule, here you're going to have this to be what? U v prime plus v u prime divided by what? Here you have divided by uv, then this one divided by uv. So that means here you're going to have this to be what? So 2 u will cancel you. That means you are going to have this to be v prime over v, then plus. Now here v will cancel v. That means you have this to be what? U prime over u. You can see that this one is you have minus sign here, so option A cannot be the right answer. Let's go to option B. Now if you check option B, I have u over v prime all divided by uv. Okay, so here if you apply a quotient rule, that means that you are going to have this to be v u prime minus u v prime, okay, all divided by what? V square. And now I have u v, okay, So that means that here I'm going to have this to be what? 1 over v square, then multiply by what? V u prime over what? Over uv minus uv prime over uv. Okay, so here you're having negative and here you're having positive. All right, so you can see that this one cannot be the what? Cannot be the right option. So let's move to option 3. So here in this option here you have this one to be u n prime all divided by u raised to power n. And if you differentiate this, you're going to have this to be what? N multiplied by u n minus 1 divided by u n. Okay, so and if you simplify this, you're going to have this to be what? N multiplied by 1 over u raised to power n minus, okay, this should be plus 1 minus n from your law of indices. And here you're going to have this to be what? N over u. Okay, n over u. So notice that this is not part of our option. Okay, so this is wrong, so this one also is wrong. And if you try the last option here, you have v over u prime. So if you apply your quotient rule, we are going to have this to be what? U v prime minus v u prime all divided by what? U square. Okay, and if you check this option here, we are having v u prime minus uv prime, which is not the same thing as this, so this one also too is wrong. So our option, okay, our answer is not part of the option, so we choose option what? Option E. All right, so let's move on to the next question. In this question, it said if y is equals to the square root of 1 minus x squared, calculate x when dy dx is 1. Here we are given y to be equals to the square root of 1 minus x squared. Okay, for us to calculate x, we need to set the y dx to be what? 1. So let's find out the y dx. Our dy dx, that is, if we differentiate y with respect to x, that means that we are going to have this to be, if we use chain rule, okay, that's if we substitute, let's say our u is equals to 1 minus x squared. So that means our y is equals to what? Square root of what? 1, that's square root of u, okay, where our u is what? 1 minus x squared. And if we differentiate u with respect to x, that means that we are going to have this to be what? Minus 2x, right? And if we differentiate y, we are going to have this to be what? 1 over 2 roots u, which is to the same thing as what? 1 over 2 roots x 1 minus x squared. Okay, so that means that using chain rule, this is dy du. Okay, so using chain rule, our dy dx is what? Dy du times du dx. Okay, so meaning that if we substitute those values, that means we're going to have this to be 1 over 2 roots 1 minus x squared, okay, multiplied by minus 2x. Okay, so this is our dy dx. Now they said we should calculate x when our dy dx is what? 1. So if we equate this to 1, so what are we going to have? We are going to have this to be minus 1 or minus x. All right, since 2 cancels to here, so that means we have minus x all divided by what? Square root of 1 minus x squared to be equals to what? 1. Okay, so that means that if we cross multiply, we're going to have this to be what? Minus x to be equals to square root of 1 minus x squared. And if we square both sides, that means we are going to have this to be what? Squaring both sides, that means we are going to have this to be what? X squared to be equals to 1 minus x squared. And if you call it like times, that means that we are going to have 2x squared to be equals to 1. Dividing both sides by 2, that means that our x squared is equals to 1 over 2. Alright, so that means that our x is equals to the square root of 1 over 2, which is what? Plus or minus 1 over root 2. Okay, so that means that we have x to be plus or minus root 2. So we have two values for x. So we need to actually test for the one that would work in this equation. So we check when our x is what? Minus 1 over root 2. So if our x is minus 1 over root 2, here we're going to have this to be what? Minus times 1 over minus 1 over root 2. Will it give us square root of 1 minus 1 over root 2 all square? Let's check. Now here you will see that this will give us 1 over root 2, okay, because 1 minus 1 over 2 is still what? 1 over 2. Then taking the square root will give us 1 over root 2, because minus will take care of this minus here, and you have this to be what? 1 over root 2. So that means this one is correct. So what if your x is equal to 1 over root 2 without having this negative sign at the front, that is when it is positive? So that means here we're going to have this to be minus 1 over root 2 to be equals to, here we're going to have this to be 1 over root 2, since we know that if we substitute 1 over root 2 at the right hand side of this equation to give us 1 over root 2. Okay, so that means we have minus 1 over root 2 to be equal to 1 over root 2, which is absurd. Okay, it's like you're having minus 1 to be equal to 1. Doesn't make sense. So that means that the correct answer to this question is what? Minus 1 over root 2, which is what? Option C. So that means option C is what? Is the correct answer to this question. So let's move on to the next question. Okay, in this question they said find the gradient of the curve y to be equals to 12 over x squared minus 4x at point x equals 3. Okay, so we have to find the gradient. For us to find the gradient, first thing is that we find the derivative. Okay, since we know that derivative will help us to find the gradient. Derivative is just still the same thing as the slope. Okay, that's the approximate slope at a particular point. Now here we are given y to be equals to 12 over x squared minus 4x, right? So here we need to find our dy dx. Now let me just quickly chip in something. Why, when you are differentiating, if you have, let's say you have y to be equals to 1 over function of x, and you want to differentiate this function quickly, all right? So how do we do that? We're going to differentiate this function, this function here, this f of x here, okay? Then we multiply by negative sign. Then after that, then we divide it by the square of that function, and we are done. Still the same concept. If you apply your quotient rule, you are still going to have the same result. Noting that what you have at your numerator here is just a constant. So that means by the time you differentiate it, it will give you 0. So that means you'll be left with what? Minus the derivative of your what? F of x divided by what? Your function. Okay, so that means what if you have this to be a constant? That means you are going to multiply your result by a constant a. Now still applying the same concept here. That means we are going to have this to be what? Minus, because this what we have at the numerator here is what? The constant. So we have minus the constant multiplied by the derivative of this function. Now what's the derivative of this function? Derivative of this function is what? 2x, right? Because if you differentiate x squared, you have 2x, then minus 4. Okay, if you differentiate minus 4x, you have that to be minus 4, then divided by x squared minus 4x all square. Okay, so that means we have that result. And now we are asked to find the derivative at a point, so that is our dy dx at point x equals to 3 would give us what? So that means we need to substitute 3 directly here. That means we have this to be minus 12, then here we have this to be 6 minus 4, okay, divided by 3 square minus 12, then raised to power 2. Alright, so let's try to use our calculator to just evaluate this instantly, and let's get the answer. Here we have this to be minus 12 open bracket 6 minus 4, then divided by 3 square minus 12 all square. So here we have this to be minus 8 over 3. Minus 8 over 3. So the correct option is what? Option B. Okay, so let's move on to the next question. In this question, it says given that the integral of dx over 4 minus x squared is equal to beta ln f of x over g of x plus k, where your k is a constant of integration. Alright, so we have to simplify this expression. Okay, now here we have the integral of dx over 4 minus x squared, in which you can still write as this 1 over 2 minus x multiplied by what? X plus 2 plus x. Okay, this is just difference of 2 square. If you use the idea of difference of 2 square, you're going to have this expression. Okay, since you know that 4 minus x square is the same thing as what? 2 square minus x square. Of course, this is x 2 minus x multiplied by 2 plus x. Okay, so that is clear enough. Now dx, okay, here that means we can still rewrite this to be what? The integral minus the integral of what? 1 over x minus 2 then multiplied by x plus 2. Okay, dx. Alright, so I just try to make sure that the coefficient of my x here is positive, in the sense that if you should look at it, if you factorize negative out here, that means if I use minus to multiply what I have here, I'm going to have this to be what? X minus 2. Okay, and it's just like I'm bringing out negative, so that means this one is having negative here. So I hope that is clear. Now if I try to resolve x minus 2, 1 over x minus 2 multiplied by x plus 2 into partial fraction, what will I get? So let's do that. So x minus 2 plus b over x plus 2. Okay, so that means that I'm going to have this to be, here we have 1 to be equals to a multiplied by x plus 2, then we have plus b multiplied by x minus 2. Okay, so that means that when your x is 2, what do we have? So when x is 2, that means that we are going to have a to be equals to 1 over 4. Okay, because if you put x to be 2 here, we are using the cover up method just from our elementary days in partial fraction. So this one will goes to 0. Then here we have this to be what? A multiplied by 4, and dividing both sides by 4, you have this your a to be 1 over 4. And when your x is when your x is what? When your x is minus 2, okay, that means that if you substitute minus 2 here, you have 8 multiplied by 0, which is still what? 0. Then here we have this to be minus 2, that means our b is going to be what? Minus 1 over 4. Alright, so that means here, that means this integral minus the integral of 1 over x minus 2 multiplied by x plus 2 dx, alright, can be written as what? Minus, that's minus the integral of what? A, which is, what's our a? That's 1 over 4. 1 over 4 multiplied by x minus 2 dx. Okay, then minus b, that means this will change to plus because our b is minus. That means minus times this minus here will become plus, then the integral of 1 over 4 open brackets what? X plus 2 dx. Okay, and if you integrate this, that means we're going to have this to be what? Minus 1 over 4 multiplied by ln x minus 2. Okay, then here we have this to be plus what? 1 over 4 ln x plus 2. Okay, so you notice that if you differentiate x plus 2, you are going to have 1. And from your elementary days in integration, you know that if you have the integral of the derivative of a function over the function, alright, this is just the ln of the denominator. Alright, so this is clear enough. So that's why I'm having this to be ln of my denominator, since I know that if I differentiate x minus 2, I will have 1 Okay, so that means I will have that's the lane of the denominator. And here, if I invoke the fact that lane A plus lane B, or let's say lane A minus lane B, is what? Lane A over B. Okay, so if I invoke this fact, so that means I'm going to have this to be 1 over 4 lane x plus 2 over x minus 2. Since this one is negative, so that means I'm going to have this to be lane x plus 2 divided by lane x minus 2, then plus your constant of integration. All right, so what do you notice? That means my beta is what? 1 over 4. My f of x is what? X plus 2. And my g of x is what? X minus 2. So I'm asked to evaluate beta, that's 1 over 4, multiplied by f of x, that's x plus 2, then plus g of x, that's what? Plus x minus 2. Okay, so what do you notice? We have this to be what? 1 over 4 multiplied by, now 2 minus 2 will give us 0, and x plus x will give us what? 2x. So that means I'm going to have this result to be x over 2. I can't find my answer in the option listed above, so this is actually the correct answer. Okay, if you don't believe me, you can solve it over and over and over again, but I'm sure that this is the correct answer. All right, so our answer is not part of the option, so we just choose option E. All right, because this is this exam was written like this was a physical exam, so there's this instruction that states that if your answer is not part of the option, you can choose option E. However, since you guys are writing it online, I just pray that most of your answer are part of the question. All right, so that one is just by the way. Let's just move on to the next question. Okay, so in this question, you are asked to find the derivative of sine x squared. This is just chicken change. Here you have y to be equals to sine x squared. All right, so what's your dy dx? Now if you check the arguments here, this is a function of x. All right, the primitive function is just a function of x. That is, I'm having u to be equals to x squared. All right, so that means that if I use my chain rule, that means my y is going to be what? Sine u. And if I differentiate u with respect to x, I'm going to have 2x. If I differentiate y with respect to u, I'm going to have what? Cos u, which is still the same thing as what? Cos x squared. So if I multiply these two results together, I'm going to have my dy dx to be equals to dy du times what? Du dx. So what's my dy du? My dy du is just what? Cos x squared. And my du dx is what? 2x. So I have my result. So I have 2x multiplied by what? Cos x squared. So that means the correct answer to this question is what? Option B. All right, so we have this to be our option B to be the correct option. So let's just move on to the next question. In this question, they said the implicit differentiation of 2y plus sine y minus x is equal to 0 is what? Now here we have this to be 2y plus sine y minus x to be equal to 0. Now if you differentiate each term here with respect to x, that's 2y plus d dx of sine y minus d dx of x, then to be equals to d dx of 0. Of course, if you differentiate 0, you still have 0, so I can still leave it like that. Now here I can write this as what? 2 dy dx. All right, then plus. Now what do you notice? You see that this is a function of y, and I want to differentiate it with respect to x. Again, I can actually manipulate it in such a way that I will have this to be dy of sine y. Okay, so I have this to be dy of sine y multiply by, now since this is a function of y, all right, and I've differentiated it with respect to y, then immediately I'll multiply by the y dx. Okay, because if you still use your idea of chain rule, the y will cancel the y, so I'll just be left with what d dx of my sine y. All right, so then minus, if you differentiate x with respect to x, you have this to be 1, then you have this to be 0. All right, so now I will have this to be 2 dy dx, then plus differentiate sine y, you have this to be cos y, then multiply by dy dx, then to be equals to 1. That is if you bring 1 to the other side. Okay, so that means we have that result. So here you can have our dy dx to be equals to 1 over 2 plus cos y. So that means the correct answer to this question, or the correct option to this question, is what? Option C. Okay, because this looks like our answer, so this is the right option. So let's just move on to the next question. In this question, we have to find the limit at which x tends to 1 over square root of 2 of x squared minus 1 over square root of x, all divided by x minus 1 over square root of 2. Now, if you should look at this question, okay, by direct substitution, let's check it by direct substitution first. The limit at which x tends to 1 over root 2, okay, is what? If I substitute this directly, what am I going to have? I'm going to have this to be 1 over square root of 2 all square minus 1 over square root of 2 all divided by 1 over square root of 2 minus 1 over square root of 2. So here at the numerator, I'm having 1 over square root of 2 all square, which will give us like 1 over 2. This will just give us 1 over 2. Then I have 1 minus 1 over square root of 2 divided by, here I'm having 0. Okay, so you can see that the numerator is not tending to 0, but the denominator is tending to 0. That means this solution to this question is what? Undefined. That's the answer to this question, is undefined. However, I can't use my L'Hopital's rule because I'm not having 0 over 0. Suppose I'm having 0 at the numerator, that is by direct substitution, and I'm also having 0 divided by 0 from my denominator. So that means I can conveniently apply L'Hopital's rule, that is, I'm going to differentiate the numerator and also differentiate the denominator, then substitute the value of then substitute your x. Okay, this value here, then substitute directly into that limit, you get your answer. But here, when I substituted directly, I'm having a constant over 0. That is what? Undefined. Alright, so the answer to this question is what? Option E. Our answer is not there. This is not the limit. 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 Alright, so that's just the answer. And you can test it with any software. I could have shown you on Maple. Now, this is a math software in which we can use to calculate and do our symbolic calculation. So I've just inputted the arguments inside this console, and now let's try to evaluate this. Let's see what the computer will give us, because I believe the computer is more correct than, I just use the computer to cross-check my calculation sometimes. So let's see what this will give us. And I've pressed enter. So it's evaluating. So what do you have? That means you have this to be what? Undefined. So that means I'm right. Okay, now let's just continue. That is just for us to confirm with the software. This is just like with the math software. You can use any math software. You can use your Wolfram, you can use your MATLAB, you can use anything to confirm. You see that this will still give you undefined. So let's just move on. So this is what's undefined. So that means our answer is not part of the question. So alright, let's just move on to the next question. In this question, we asked to evaluate e raised to the power. You have this to be e raised to the power of integral of 1 over x dx. Now this is very simple actually, because I know that if I integrate 1 over x dx, it will give me what? Ln x, right? And here this is the same thing as your x. Okay, from your fact that if you have a number a, your number a can be written as what? E raised to the power ln a. So still the same concept. This is just what? The value of x. So that means our correct answer is what? Our correct option here is what? Option C. Alright, let's just move to the next question. Alright, in this question it said if 12x squared y cubed plus 3y squared is equals to 1, find the value of the y dx at 1, 1. Alright, so here we can use our implicit. This is an implicit function, so we can use our implicit differentiation. Now here we have this to be 12x squared y cubed plus 3y squared to be equals to 1. So that means that if I differentiate each term with respect to x, so that means I'm going to have this to be ddx of 3y squared, then this to be ddx of 1. Okay, now here I can actually apply my product rule. Okay, so that means I'm going to have this to be 12x squared multiplied by ddx of y cubed plus 12y cubed. Alright, then this multiplied by ddx of x squared. Okay, so then that's that, because here we have this constant, so that means it's constant. We multiply each of them, each of the differentials, then plus. Now here, since this is a function of y, so that means we are going to have this to be ddy of 3y squared, then multiply by dy dx. Of course, you know that if you differentiate 1, this will give you 0. So now again, I'm going to have this to be what? X squared multiplied by, now this is y cubed, right? And you want to differentiate it with respect to x. So that means here we're going to have this to be what? D. So we have this to be dy of y cubed, then multiplied by dy dx, then plus 12y cubed, then multiplied by, if you differentiate this with respect to x, that means you have this to be 2x, then plus, if you differentiate this with respect to y, that means you are going to have this to be 6y, because this is 3y squared, then multiply by dy dx to be equals to 0. Alright, here that means we are going to have this to be 12x squared, then this is 3y squared multiplied by dy dx, then plus this is 24xy cubed, then plus 6y dy dx to be equals to what? To be equals to 0. Now we can actually substitute our x to be 1 and y to be 1. So if we substitute x to be 1 and y to be 1, that means that this will give us what? This will give us 12 times 1 times 3, that's what? 36. Then dy dx to be plus what? Plus 24, then plus this is 6 dy dx, okay, to be equals to 0. Then that means that we are going to have this to be 36 plus 6 give us 42 dy dx to be equals to what? Minus 24. Then that means our dy dx at 1, 1 is going to be what? Minus 24 over 42, which will give us minus 24 divided by 42 will give us minus 4 over 7. So we have this to be minus 4 over 7. That means the correct option here is what? Option A. So let's move on to the next question. In this question, it said we are asked to evaluate the integral of what? Of 6 all divided by 3x minus 2 all squared. Okay, from 1 to what? From 1 to 2. So here we have 6 over 3x minus 2 all squared dx. Here we use our integration by substitution. That is, if we let u to be equal to 3x minus 2, that means our du is going to be what? Is going to be 3 dx. Alright, so that means our dx is what? Du over what? Over 3. Alright, so since we are using substitution, that means we need to also do what? We need to also change our limit of integration. Okay, so we are going from x to u. Alright, we are changing our variable from x to u. So that means that when x is what? When x is 1, u will be what? So if you substitute 1 here, that means our u is going to be what? 1. When x is what? 2. So that means what will be our u? Our u is going to be what? 4. Okay, so that means that the integral from 1 to 2 of 6 over 3x minus 2 all square dx is simply the integral from 1 to 4 of what? Of 6. 6 square is 36, so I can break 36 outside. Then I'll have what? 1 over u square multiplied by what? Multiplied by du over 3. So because our dx is what? Du over 3. So that means I'm going to have this to be 36 divided by 3 will give us 12. So that means I have 12 integral of 1 to 4 of 1 over u square du. And here you're going to have this to be 12 multiplied by, now if you integrate 1 over u square, I'm going to have this to be what? Minus 1 over u. Alright, so then from 1 to 4. Okay, so if I substitute 4 here, I'm going to have this to be minus 1 over 4 plus 1. Okay, which is what? 12 multiplied by, now 1 minus 1 over 4 will give us 3 over 4, which will give us 3 times 3 will give us 9. So the correct option here is what? Option B. Option B. Alright, so let's move on to our next question. In this question, we have to evaluate the integral from 0 to pi of x squared sine x dx. Now for us to evaluate this, we need to use our integration by parts. Now you recall that from your conventional integration by parts, let's say you have the integral of u dv. Okay, the integral of u dv itself is what? uv minus integral of v du. Alright, now here is how it works. Okay, I want to use another way in which we can evaluate this. Now let's say we have, two functions. Let's say we have u and dv. Let me draw a table down here. Okay, so let's call this the DIDI method, because with this method you can actually integrate the function fast without even wasting too much time. But let's just see how it works. Now let's call this our sine, and let's call this our differentials, and let's call this our integrals. Okay, now here I'm going to have this to be plus minus, because what you notice here, what is the sign in front of uv? That's plus. So that means I have this to be plus minus plus minus, like that. Okay, and here I'm going to put my u here, and here I'm going to put my dv here. So here I'll keep differentiating this, and here I'll keep integrating this. So if I differentiate this, what am I going to have? I'm going to have this to be what? To be my du. And if I integrate this, I'm going to have this to be what? To be v. Okay, like I said, I'll keep differentiating. Alright, so the question is that when will I stop differentiating? When will I stop differentiating and when will I stop integrating? I'm going to stop if the product of my rule, if I can integrate the product of my rule conveniently. Alright, if I can integrate the product of my rule conveniently, then that's when I'm going to stop. So that means that from this table, how do I read this table now? That means I'm going to have this to be plus u multiplied by v. That will be what? That means the integral of u dv is going to be what? Plus u multiplied by v. That means I'm going to have this to be what? uv. Alright, then this would be the next one would be what? Du, that is what I have here, multiplied by the integral of the next. Let's say when I integrate this, I have the integral of v. All right, so that means this one is going to be what? Du multiplied by the integral of v. Okay, so that means I'm going to have this to be what? Minus the integral of v du. Okay, so now here the thing is that I'm going to stop here. I'm stopping here because I know that when I integrate v and du together, I can actually conveniently integrate v and du together. Okay, what I'm saying is still nonsense to you. Okay, but let me just illustrate that with an example. Now let's say I want to integrate, let's take for example, let's say I want to integrate x raised to the power of 4 multiplied by ln x dx. Okay, so I want to use this method. They call it the DIDI method. All right, so this is what I want to say. Now again, we draw our table, right? So let's draw our table, and here we have our sign, then here we have our differentials, and we have our integrals. So here we have plus, minus, plus, less. So let's just stop here. Now our d is our choice of u. Okay, from your normal integration by parts class, we use the word islets to determine our choice of u. So anyone that comes first will become our u. This I stands for inverse function, this L stands for logarithmic function, this A stands for algebraic function, this T stands for what? Trigonometric function, and this E stands for what? Exponential function. All right, so that means our d would be what? In this case, our d would be what? Ln x. Since we know that ln comes before algebraic, so that means our d is going to be what? Ln x. So what will be our I? Our I is going to be what? X raised to power 4 dx. All right, so let's just put x raised to power 4. So what we are going to be doing here, we are going to be differentiating this, and here we are going to be integrating this. But when are we going to stop? We are going to stop if the product of, if I can integrate the product of my rule. Now let's differentiate this. If you differentiate ln x, what am I going to have? I'm going to have this to be what? 1 over x. And if I integrate x raised to power 4, I'm going to have this to be what? X raised to power 5 over what? Over 5. Okay, I can differentiate this. Okay, I can differentiate this further, and I can integrate this further. But I'm going to stop here, since I know that if I multiply x raised to power 5 multiply by 1 over x, I can easily integrate that. So I'm just going to stop. I'm just going to stop here. All right, so that means that here this will give us what? Plus ln x times this times x raised to power 5 over 5. So this will be what? X raised to power 5 over 5 multiplied by ln x, then minus, okay, minus, so I will just take the product of the integral. So that means I'm going to have this to be what? X raised to power 5 over 5 multiplied by 1 over x dx. So that means I can simplify this to be what? Ln x minus, so if I simplify this, I'm going to have this to be integral of 1 over 5 x raised to power 4 dx, which I believe that every one of us can finish this up. Now let's come back to our normal question. Here we are given the integral from 0 to pi of x squared sine x dx. Now let's say I'm not even given the limit of integration. Let's say I don't know I'm not given the limit of integration, just like normal indefinite integral. So I want to use the integration by parts to evaluate this, then use my substitution to find the value. So here again, I draw my box, I put my sign, then here I have my differentials and I have my integrals. Okay, so here now, what will be my choice of u? My choice of u here will be what? Will be x squared, because I know that algebraic comes before trigonometric. So that means this will be what? X squared. And what will be my I? My I is going to be what? My I is going to be sine x. So here I keep differentiating, and here I keep integrating. But don't forget, I'm going to stop when I know that I can easily I can easily find the product. When I multiply two rows together, all right, I can easily find the integral. Okay, so let's do that. If you differentiate 2x, I'm going to have, if you differentiate x squared, I'm going to have 2x. Again, if you differentiate x, I'm going to have 2. Okay, since I have a constant, I know that I can easily find the integral of what of any function that is not, that is not like, I'm not having like two different functions, like the integral of f of x and g of x. Okay, if it's just like one function, I can easily find the integral using normal standard integral table. Okay, now let's integrate this. If you integrate sine x, I'm going to have this to be what? Minus cos x. Okay, and if you integrate cos x, I'm going to have this to be what? Minus sine x. Again, you use your normal conventional sign, minus and plus, like that. Here I'm stopping here because I know that I can, if I take the product of 2 and minus sine x, I can easily find the integral. So that means that this is just simply x plus x squared multiplied by plus x squared multiplied by minus cos x. That means I'm going to have this to what? Minus x squared cos x. Okay, then here again you pick minus 2x multiplied by minus sine x. That means we are going to have this to be what? Plus what? Plus 2x sine x. Then lastly, we now have plus the integral of 2, because here plus times minus will give us minus, so this should be minus, this should be negative, this should be negative. You can see that the last expression here is carrying an integral. Our last expression here is carrying an integral. Our last expression here is having an integral. So the integral of plus times minus will give us what? Minus 2 sine x dx. Alright, so we can finish this up. That means we have this to be what? Minus x squared cos x plus what? 2x sine x. Then here we have this to be, we have this to be plus 2, because if you integrate sine x, we are going to have this to be what? Minus cos x. So that means minus times minus will turn to plus. Then we have this to be what? Plus 2 cos x. Okay, so I'm just using this trick. If you are not given, let's say you don't know you are not given the bound. Okay, so but here we are given the upper limit to be what? To be pi, and the lower limit to be 0. So that means that if we invoke the upper limit and the lower limit, so that means the integral from 0 to pi of x squared sine x dx is going to be minus x squared cos x plus 2x sine x. So here we have this to be 2x sine x, then plus 2 cos x, then we have 0 to what? To pi. Okay, so if we substitute the value of pi, you know that, so what's our pi? So that means we have this to be minus pi squared, and cos pi would give us minus 1. Okay, then plus 2 pi sine pi will give us 0, then plus what? Plus 2 cos pi will give us minus 1. Okay, minus the lower limit. Here we have this to be 0, because cos 0, because 0 squared is still what? Still 0. Then 0 multiplied by cos 0 will still give us 0. Then here also we also have this to be 0. Then from the last one, then we have this to be what? Since cos 0 is 1, so that means we have this to be minus 2. Then if we simplify this, we are going to have this to be what? Pi squared minus 2 minus 2. So that means we have this to be what? Pi squared minus 4. So the correct option here is what? Option B. Okay, here you can see minus 44. This might be a typo error from the people typing the question. So the correct option here should just be option B, because we have pi squared minus 4 minus 44. So in case when you are doing your solution and you see that, okay, this is like having 44, just pick option B. Okay, it might be typo error. If you say, oh, the answer is not there, and you go and choose option E, you've got it wrong. So this might be this is very close to the answer. It might just be typo error. Okay, so yeah, our option here is what? Option B. So let's just go ahead to the next question. In this question, they said the equation of a curve is such that dy dx is equals to 3 over square root of x minus x. Given that the curve passed through the point 4, 6, so we have to find the equation of a curve. I know that the equation of a curve will always be y to be equals to a function of x, right? And here I'm given my dy dx to be equals to 3 over square root of x minus x. Okay, so that means that my dy is going to be what? 3 over square root of x minus x, then multiply by dx. So that means if I integrate both sides with respect to x, if I integrate this with respect to y and I integrate this with respect to x, so that means I'm going to have this to be what? Y is going to be equals to, if I integrate this, that means I'm going to have 3, this is square root of x raised to power minus 1 over 2, which is still the same thing as 6 square root of x. Okay, because if you integrate square root of x, it will give you 2 root x. Okay, sorry, 1 over square root of x, this will give you 2 root x, since you know that this can be written as x raised to power minus 1 over 2. Okay, and if you add 1 over 2 to, if you add 1 to this, that means you have this to be 1 over 2. That means this can still be written as 2 root x. So this is just pretty much clear. So let's just rub this off. Now, minus, if you integrate x, that means you are going to have this to be what? X squared over 2 plus your arbitrary constant k. Okay, now you are given that when your y is what? When your x is 4, your y is what? 6. That means if you substitute y to be 6 here, and here we have this to be 6 square root of 4 minus this to be 4 square over 2 plus k. That means your k is going to be what? 6 minus, this is what? 12 minus 8. Okay, so that means this is going to be what? This should be plus because you are taking it to the other side. No, this should be minus, then this should be plus. So 6 plus 4, 6 plus 8 is 14. 14 minus 12 is what? Is 2. So that means our curve is going to be what? 6 root x minus x squared over 2 plus 2. So the correct answer, or the correct option to this question is option A. So this should be option A. Alright, so option A. So let's move on to the next question. In this question, they said find the maximum value of the function f of x to be equals to x multiplied by x minus 1 on this interval. Find the maximum value. I guess this question is wrong. It should be minimum. How do I know? Because this is a quadratic equation, right? And if the coefficient of x, if you multiply this out, you are going to have this to be what? F of x to be equals to x squared minus x, right? And by default, I know that this quadratic equation will look like something like this. So this should be minimum. They should be talking about minimum, not maximum. So this should be minimum. All right, so I don't think you can see it. This is minimum. Okay, so that's just a correction on my own part. Maybe the people who set in the question, maybe they didn't actually look at the question very well. Maybe it might be typo error. Okay, which can happen. All right, so the question here is that we want to find the minimum value of the function. Minimum value of the function on this interval. All right, so first thing is that we differentiate our function. That means we have this to be x plus x minus 1. Okay, if you differentiate this using your product rule, that means you have x multiplied by the differential, which is still 1, plus x minus 1 multiplied by x, the differential of x, which is still 1. So that means I have this to be 2x minus 2. Alright, so this is the differential of our function. The next thing is to set our differential to be what? Differential of our function to be what? 0. So that means I'm going to have this to be 2x minus 1 to be equals to 0. And that means that my x is what? 1 over 2. Okay? Of course, in this interval, 0, 1 over 2. Okay? You can see that this is actually part of my point. So, I'm good to go. Alright, so this is actually the critical point. This is our critical point. Even if you take the second derivative of x, you are still going to have this to be positive. Okay, and once it's positive, that means it's what? It's minimum. That's where I know that this is actually wrong, because if it is negative, then that's when it will be maximum. This is positive, that means it is what? Minimum at this point. All right, so since that is minimum at this point, so that means our minimum value would be what? Minimum value would be 1 over, so this is actually 1 over 2. So that means the correct, so that means the minimum value is at point x equals to 1 over 2. So that means if we substitute it back into our function, so that means f of 1 over 2, that will give us 1 over 2 multiplied by 1 over 2 minus 1. So that means that we have this to be minus 1 over 4. So that means the x minimum value is 1 over 2, and the y minimum value is what? Minus 1 over 2. So I'm not too sure of the minimum value they are asking me to look for, whether it is the x minimum value or the y minimum value. Okay, so I will just go with option C. All right, so since at least one of my answer is there. Okay, because when you talk about minimum value, we need to state whether is it the x minimum value or the y minimum value. All right, so the question is not clearly stated. I will just go with option C. All right, so let's move on to the next question. In this question, we're asked to find you are given u to be equals to ln of x squared plus y squared, then plus arctan of y over x. So we asked to find di square u di x squared, then plus di square u di y squared. Okay, I've done this before in my previous video, but I will just redo it again. All right, so here we are given u to be equals to ln x squared plus y squared. So that means our di u, oh, I'm not done. So this should contain plus arctan of y over x. Okay, so that means our di u di x, you are taking the partial derivative of u with respect to x. That means you will keep all other variable as constant. Okay, so if you should do that, that means that since I want to differentiate this with respect to x, and this is like ln x squared plus y squared, that means I'm going to apply my normal rule for differentiating ln of a function. And how do I do that? I differentiate what is inside this function partially with respect to x. So anytime you are differentiating, you just have it at the back of your mind that you are differentiating the argument partially with respect to x. Okay, so that means if we do that, that means we have this to be what? 2x over the function, that's x squared plus y squared, and you are done. And now you want to differentiate this partially with respect to x, but here I'm having a constant over x. So that means I need to differentiate what's inside here partially with respect to x. So if I do that, that means I'm going to have this to be minus y over x squared. We've done that before. That is, if you are differentiating 1 over function of x, that means you are going to have that to be negative of the differential of that function, then multiplied by the square of that function. But since you're having y here, that means I have y over x squared. I think that is pretty much clear. And now you want to differentiate, just like normal chain rule, you now want to differentiate this with respect to what? Y over x. So that means I'm going to have this to be 1 over 1 plus y squared over x squared. It's just like if you differentiate arctan of x. Differentiating arctan of x will lead to 1 over 1 plus x squared. So this is pretty much clear. That means I'm going to have this to be what? 2x over what? X squared plus y squared minus y over, so if you use x squared to multiply this denominator, you're going to have this to be what? X squared plus y squared. And now I'm going to have my du dx to be equals to 2x minus y over x squared plus what? Y squared. Again, if I want to find my second partial derivative of u with respect to x, okay, so that means I'm going to have, so using my quotient rule, so that means I'm going to have this to be what? So if I use my quotient rule to differentiate this guy, so that means I'm going to have this to be x squared plus y squared. All right, so if you differentiate 2x minus y partially with respect to x, I'm going to have this to be 2, then minus 2x minus y, then differentiate the denominator partially with respect to x. I'm going to have this to be what? 2x, then all divided by what? All divided by the denominator, that's x squared plus y squared all square. Alright, so that means I can simplify this to be that u die square u die x square would be what? 2x square plus 2y square. Then if I multiply this out, I'm going to have this to be what? Minus 4x square. Then here I have this to be what? Minus 2xy all divided by x square plus y square all square. Okay, I think I'm done with that. So let's do the other side. Here I want to find the partial derivative of u with respect to y. Again, let's do that again. So if this is our u and I want to take the partial derivative with respect to y, I differentiate what I have here with partially with respect to y. This is just 2y over the function itself, that's x squared plus what? Y squared. Then plus here I have y over x, okay, arctan of y over x, and I want to differentiate partially with respect to y. That means I will differentiate y over x partially with respect to y. That means this will give me what? 1 over x. If you differentiate y partially with respect to y, you have that just to be what? 1. Then multiply by your 1 over x, that will be what? 1 over x. Then times, like your normal chain rule, you need to differentiate arctan of y over x with respect to y over x. Okay, that means I'm going to have this to be 1 over 1 plus y over x all square. Okay, I hope that is pretty much clear. Here this is not ordinary, this assuming this is ordinary y, now that's when we can now have this, but this is like having y over x. It's like you're having another function of y. That means you need to differentiate that function of y partially first with respect to y, then you now multiply it by the normal derivative of arctan of your argument. All right, it's just like we are making y over x. You get what I'm saying? It's just like you are making y over x to be what? To be u. Then you differentiate u partially with respect to what? Y. Then after that you now differentiate what you have here partially with respect to u. You can even take the total derivative. There's nothing wrong with that because it's just like a single variable. So we can still use the word partial, okay, to differentiate that with respect to. Let me just illustrate what I'm saying. This is what I'm saying. Let's say you have this to be, if I let my y over x to be equals to u. All right, so that means if I take the partial derivative of u with respect to y, I'm going to have this to be what? 1 over x. Sorry, x. Yes, 1 over x. That's right. And now I'll be left with what? Arctan of u. So that means I need to differentiate my arctan of u. Okay, I need to take the total derivative, like your normal differentiation of what? Of arctan of u with respect to what? With respect to u, which will give us what? 1 over 1 plus u square. So if I substitute this back, if I substitute my y over x into this, I'm going to have this result. Just with my normal chain rule, that means my partial derivative of where can I write here? So that means my partial derivative of partial derivative of u with respect to y is going to be what? Or the partial derivative of my arctan of let's call this function v. All right, so that means the partial derivative of partial derivative of v with respect to y would be what? The partial derivative of v, or the total derivative of v with respect to u multiplied by the partial derivative of u with respect to y. Okay, you can still take this to be partial derivative. I'm just taking it with like normal derivative, since this is just a function of just one single variable. Okay, this is just like v is a function of u, so I don't need to take the partial derivative. I can just take the normal derivative. Okay, so which is still like that. So this is pretty much clear. I believe that you must have done that in class. All right, so let's just move on from here. Now here I can multiply this by x and multiply this 2 by x. So that means I'm going to have this to be x over x squared. The main idea is that I want to have this to be x squared 2y over x squared plus y squared, all right, plus x over x squared plus y squared. Okay, if you use x squared to multiply this, okay, that's x times 1 will give us x squared. Then x times y squared over x squared will give us y squared. So this is pretty much clear. So this will be what? 2y over x squared plus y squared, then plus, sorry, this should just be plus x, since they have common denominator. So this is my u die y. All right, so I want to look for my die square u die y square. So this is going to give me what? X squared plus y squared. Again, differentiate this partially with respect to y. You have this to be 2 minus 2y plus x. Differentiate your denominator partially with respect to y. That means you have it to be what? 2y. Then over x squared plus y squared all square. So that means I will have this to be 2x squared. Okay, then this to be plus 2y squared, then minus 4y squared, then this to be, now if you this should be plus, because minus times minus should give me plus. Sorry, this should be plus. Then this should be minus 2xy, then all divided by x squared plus y squared all square. And if you should sum this together, that is square u over die y square, this will give us what? If you should add this together, we are going to have this to, since they have common denominator, so that means I will have this to be 2x squared plus 2y squared minus 4x squared plus 2xy, then plus 2x squared plus 2y squared minus 4y squared minus 2xy, all divided by what? All divided by x squared plus y squared all square. And now what will this give you? This is 2x squared minus 4x squared, that will give us 0. 2x squared plus 2y squared minus 4y squared, that will give us 0. Plus 2xy minus 2xy will also give us 0. That means our final answer is just what? 0. So anytime you see this question, okay, anytime you see this question surfacing, just know that your answer is just what? 0. You don't need to solve anything, just know that your answer is 0. So here in this question, we have to evaluate this, obtain the integral of sine 2x over x over sine x dx. Okay, here we have this to be sine 2x itself is what? 2 sine x cos x. All right, then divided by sine x. So that means we have this to be the integral of 2 cos x, and that means we have this to be 2 multiplied by integral of cos x dx. All right, and now if you integrate cos x, you're going to have this to be sine x. So this is simple. So our correct answer is what? Option C. All right, let's move on to the next question. In this question, it said use integration by parts. Oh, lovely. So using that same method, okay, we want to find using integration by parts the integral of this value. Now for us to do that, we can actually draw our table. So let's drop our table. Okay, so we have this to be our sine, this to be our differentials, and this to be our integral. So what to be our choice of using this eyelets? Okay, here we have logarithm before algebraic. So our logarithm here is what? Ln x. Then our algebraic here will be what? 1. Okay, so that means if you differentiate this, you are going to have this to be 1 over x, and if you integrate this, I'm going to have this to be x. Okay, you know that if I take the product of x and 1 over x together, I can easily integrate that. That's right. So I stop here. So that means that the integral of ln x dx is what? So we take it like this. That's plus ln x multiplied by x. That means I'm going to have this what? X ln x. Then since I'm stopping here, so that means I will just multiply all this together and I put integral sign at the front. Then that's what? 1, that's x times 1 over x times x dx. So that means I have this to be what? X ln x minus, this will give us 1. If you integrate 1, you still have x. Okay, so if I now invoke the bound, that's 2 to 4. Okay, so that means I'm just going to have this to be lower limit to be 2 and the upper limit to be 4. And if I evaluate this, I'm going to have this to be what? 4 ln 4 minus 4, then minus 2 ln 2 plus 2. Okay, because of this negative sign here. And 4 itself can be written as what? 2 raised to power 2. So that means I'm going to have this to what? 8 ln 2 minus 4 minus 2 ln 2 plus what? 2. And this is what? 6 ln 2 minus 2. 6 ln 2 minus 2. That means the correct option here is what? Option A. In this question, we're asked to evaluate the integral of square root of 1 plus 2 sine x cos x dx. Okay, now for you to evaluate this integral, if you should think about it, the best way to evaluate this integral is to make sure that I turn what I have here to a perfect square. Because if I can turn it to a perfect square, then I can remove this to the square root. Now, what do you observe? You observe that, you must always observe in math. Observe that what? My 1 can still be written as what? Sine square x plus what? Cos square x. Okay, that means if I substitute it directly here, I'm going to have the square root of sine square x plus 2 sine x cos x, then plus cos square x. Now the question is that, can you see what I'm saying? Can you see what I'm saying? Now what do you observe again? You should observe that anytime you have a square plus 2ab plus b square, this is what? This is just a plus b all square, right? Yes. So here, if we take our a to be sine x and we take our b to be what? Cos x, we are going to have this result, right? So that means that I'm going to have this to be square root of sine x plus cos x all square dx, and this is now a perfect square. So this will cancel this. That means I'm going to have the integral of sine x plus cos x, okay, dx. All right, now I can easily integrate this guy here And if I do that, if you integrate sine x, don't forget that you always have negative cos x. And if you integrate cos x, you have positive sine x. Then here we can write this as sine x minus cos x. So the correct option to this question is what? Option D. Okay, so the correct option here is option D. So now, using the same idea, so anytime you are asked to integrate, so you can actually integrate this on your own. So what is the integral of 1 plus let's say we have this to be sine 1 plus sine x. Okay, so you can actually find the integral of 1 plus sine x dx. So if they give you this question now, let's say they give you this question in your exam, what will be your answer? So let's just leave that. You can leave your answer in the comment section box below. All right, so if you can actually solve this integral, you can drop your answer. I'm not going to give you a prize, but using this same approach, let me just give you hints to this question. The hint is that you know that sine 2x is what? 2 sine x cos x, right? So that means my sine x itself will be what? 2 sine x over 2 cos x over 2. So if you should invoke that the fact that my sine square x over 2 plus cos square x over 2 is equals to 1, no, this integral can easily be solved. All right, so just using the same concept, anytime you see a question like this, you can try out this approach to quickly break down your integral. All right, since you understand this question, why don't you give this video a like button, and probably if you have not subscribed, you can also subscribe to this channel. All right, so let's just move on to our next question. All right, in this question they said function f and g are defined by f of x to be equal to 2x plus 1 and g of x to be what? X squared minus 1. Find the values of a for which f of g of x is equal to g of f of x. All right, in this question here they said f of g of x. So what's our f of g of x? F of g of x is just, we are substituting the value for g of x into f of x. That means we have this to be what? 2 into x squared minus 1, which will give us plus 1, which will give us 2x squared minus 2 plus 1, which is what? 2x squared minus 1. And g of f of x is what? 2x plus 1 all square minus 1. So that means here we have this to be 4x squared plus 4x plus 1 minus 1, which is what? 4x squared plus 4x. Now if we equate this together, that means we have 2x squared minus 1 to be equal to 4x squared plus 4x. And here we are going to have this to be, if you call it like times, that means we have this to be 2x squared, then plus, probably plus 4x, then plus 1 to be equal to 0. And if you use your let's use our calculator to do this. So press mode, press 5, and press 3, then we press 2, 4 and 1. So we have this to be minus 2 plus root 2 over 2. Then here we have this to be, we have x to be minus 1 plus or minus square root of 2 over 2. So the correct answer to this question is what? The correct option to this question is what? Is option A. All right, so let's move on to our next question. In this question, we have to evaluate the limit at which x tends to 1 of x minus 1 multiplied by square root of 2 minus x, all divided by x squared minus 1. Actually, if you should check by direct substitution, you will see that we are going to have 0 divided by 0 divided by 0. That means we need to simplify. We need to simplify our expression. So that means here we have the limit at which x tends to 1 of x minus 1 multiplied by 2 minus x over, now if you should observe this denominator, here I have x squared minus 1, which is still something as what, x plus 1 multiplied by x minus 1. So that means here I have x minus 1 multiplied by x plus 1. X minus 1 will cancel x minus 1. That means I'm going to have the limit at which x tends to 1 of square root of 2 minus x over x plus 1, which is what? 1 over 2. So the correct answer here is, the correct option here is option B. In this question, we are asked to obtain the antiderivative of sec x raised to the power 5 multiplied by tan x. So here we have sec x raised to the power of 5, okay, multiplied by tan x dx. Now you observe something that I can write this as what? I can write this as sec 4x multiplied by sec x tan x. And why am I doing this? You will recall that, or you remember that if you have the integral of f of x, okay, the key point here is that anytime you have the integral of f of x raised to power n multiplied by the derivative of f of x dx, this is just simply f of x raised to the power of n plus 1 over n plus 1. Okay, and if you should apply this here, what do you notice? You notice that if I differentiate here, I have something like this. I have the integral of sec 4x multiplied by the derivative of sec x, right, dx. You notice that if I differentiate sec x with respect to x, I'm going to have sec x tan x, and here I have sec x raised to the power 4. So that means my answer will just be what? Sec x raised to the power 5 over 5. That's all. So your answer is just this option. That means the correct option to this question is what? Option A. Alright, so let's move on to the next question. In this question, they said that if in the theorem f of b minus f of a to be equals to b minus a multiplied by the derivative of c, if your f of x is equals to x squared plus 3x plus 1 in the interval 1, 3, then c equals to what? Okay, this is actually known as your mean value theorem. Alright, so but here they gave us the condition that f of b minus f of a is what? F of b minus f of a divided by b minus a is what? Is your f of c prime. Okay, what the theorem is actually saying is that suppose you have like a continuous function, alright, between the points a and b, okay, between the points a and b, alright. So what this theorem is saying is that if I should draw a second line between my f of a and my f of b, I get what I'm saying. Alright, what this theorem is saying is that there will be a point between a and b. Let's call that point c. Alright, let's call that point c. I get what I'm saying. There will be a point in which if I should draw the slope at that point, I get what I'm saying. The slope and the second point will be parallel to each other. They'll be parallel to each other. So that's what this theorem is just saying. But that is probably not in this course. That's probably if you are taking the course reanalysis, that's when this can be explained to you. But this is just the schematic diagram of what this theorem is saying. All right, let's just continue. It said here we are given function f of x to be equals to x cubed x squared plus 3x plus 1. And by the way, you can check this from any classical calculus textbook. You can check this from the early transcendental calculus written by Thomas. I can't remember for now, but I'll just put the book. I'll put the book in the description box below, and you can get it from Amazon. All right, so let's just continue. If you have your f of x to be equals to x squared plus 3x plus 1, that means the derivative of f of x would be what? 2x plus what? Plus 3. All right, now if I substitute the value of c here, that means I'm going to have my f of c to be equal to 2c plus 3. Alright, so here, what's my f of b? My a, from your interval here, my a is what? My a is 3, my a is 1, and my b is what? My b is 3. So what's my f of b minus f of a? Okay, my f of b minus f of a is just simply if I substitute 3 inside this place, so that means I'm going to have 9 plus 9 plus 1. That means 9 plus 9 is 18 plus 1 is 19. So I have 19 minus, if I substitute 1, I'm going to have this to be 1 plus 3 plus 1. That means I have this to be 1 plus 3 plus 1. That's just 19 minus, this is 4 plus 1, that's 5. That means I have this to be 14. So f of b minus f of a is what? Is 14. Then over b minus c, that's 3 minus 1, that's 2. That means I have this to be 7. Okay, so here, that means that I have 2c plus 3 to be equal to 7. So if I collect like times, that means I'm going to have 2c to be equal to 7 minus 3, which is 4. Then divide both sides by 2. That means I'm going to have c to be 2. Okay, now what this theorem is saying is that, let's say I have my function f of x to be equal to x squared plus 3x plus 1. Let's say this is the function. This is how the function looks like. I think probably the function should look like this. Something like this. Let's say it's like something like this. I don't know. So what they are saying is that, or let's say something like this. Okay, what they are saying is that between this interval 1 and 3, I get what I'm saying. Between this interval 1 and 3, at point 2, all right, at point 2, the slope at this point, I get what I'm saying, will be parallel to the second line. All right, will be parallel to the second line between 1 and what? Between points 1 and 3. All right, second line is just a line joining 2 points on the curve, or more than 2 points, or probably 2 points on the curve. All right, so if you should join that, this line here, the tangent line at this point, will be parallel to the second line here. So that's what the theorem is just saying. I can check that. Like I said, you can check that from any standard calculus textbook. All right, so let's move on to our next question. All right, in this question, we have to evaluate sec cos square theta d theta from 0 to pi over 4. Okay, let's go back to, I think we've not finalized. The correct answer to this question is what? The correct option to this question is just what? Option A. Of course, that means our correct answer here is what? Option A. So let's move on to the next question properly. Here we have to evaluate the the integral of cos square theta d theta from 0 to pi over 2. Now you recall something that from your trigonometric identity, that cos square theta itself can be written as what? 1 plus cos 2 theta over 2. So here the integral from 0 to pi over 4 of cos square theta d theta is still the same thing as saying 0 to pi over 4 of 1 over 2 plus cos 2 theta over 2 d theta, right? So that means here we are going to have this to be, so if we integrate this, that means we have this to be theta over 2, then from 0 to pi over 4, then plus here we have sine 2 theta over 4, then from 0 to pi over 2, and here that means we have this to be pi over 8, then plus, so this is sine pi is what? Sine pi over 2 is this should be pi over 4. So sine pi over 2 is 1. So that means you have this to be 1 over 4. Since you know that sine 0 will give us 0, so you don't need to deal with that. So that means here we have pi over 8 plus 1 over 4, which is still the same thing as 1 over 8 open bracket pi plus 2. Okay, because if you open this bracket, you will have this result here. Alright, so that means the correct answer or the correct option to this question is what? Is option A. Option A. So let's move on to the next question. In this question, we are asked to evaluate or find the dx at point x equals to 1. Now don't forget that anytime you want to find the dx of, let's say, a function of f of x raised to the power of n, okay, here what you are going to do here is that you take n, you differentiate this function, all right, then you write the function, then you subtract 1 from the power. That's just the key point here. Okay, that's the key point here. Now let's do it again here. Let's repeat what we've done here in this question. Now here we have the dx of 5x squared minus 3x plus 1 raised to power minus 3. Here we have minus 3 multiplied by the derivative of this function. That's what? 10x minus 3. Then we repeat the function and subtract 1. That means we have 5x squared minus 3x plus 1 raised to the power minus 4. Alright, so meaning that we want to find the ddx at x equals 1. So that means our ddx of our function at x equals 1 would be what? So if we substitute 1, that means we have minus 3, then 7, then here we have this to be 5 minus 3, that's 5 minus 3 is 2, then 2 plus 1 will give us 3, then we have this to be 3 raised to the power of minus 4, that's like 1 over 3 raised to the power of 4 is 81, so we have this to be 1 over 81, which is the same as what? Minus 21 over 81. So the correct option here is what? Option B. So let's move on to the next question. Here we are asked to find the integral of x plus 1 over x squared minus x minus 1. Now you observe that x squared minus x minus 6 can be written as x plus 2, no, yes, x plus 2, then x minus 3, yes, I guess, because if you should expand this, you are going to have that result, okay, because if you expand this, minus plus 2 minus 3 will give us minus x, so that means we are right. So that means that using partial fraction, since we are able to factorize it, that means we can break this this expression here into partial fraction. So that means we have x plus 1 over x plus 2, then x minus 3. So say a over x plus 2, then plus b over x minus 3. Okay, now the trick here is that for you to find your a, because you want to find your a and b, for you to find your a, you just pick it like this, then you pick x plus 1 over, if this is your a, that means this would be x plus 1 over x minus 3. Then you substitute x to be what? To be minus 2. Okay, this will give you the value of a. Then for you to get the value of b, you pick x plus 1, then over x plus 2, then you substitute your x to be what? 3, then you get the value of your b. If you do that, so let's do that here. So that means we have this to be let's say this is our x here. Let's go back computer. So here we have absolute value of, that means we have x plus 1, then alphabet x minus 3. So that means we need to put minus 2 here. That means we have 1 over 5. Okay, for the second one we have x plus 1, then alphabet x plus 2. Here let's put 3, substitute 3, that means we have 4 over 5. So we have a to be 1 over 5 and b to be 4 over 5. Okay, so that means the integral here, integral of x plus 1 over x plus 2 multiplied by x minus 3 dx can be written as what? A. What's our a? Our a is 1 over 5, so we have this to be 1 over 5 multiplied by x plus 2, okay, dx, then plus 4 over 5 integral of what's 1 over x minus 3 dx. Of course, you know that this will give us 1 over 5 ln x plus 2, then this will give us 4 over 5 ln 4 over 5 ln x minus 3. Okay, and here if you should bring 4 here, that means I have 1 over 5 ln x plus 2 plus 1 over 5 ln x minus 3 raised to power 4, okay, from your law of logarithm. And that means that you have this to be 1 over 5 ln x minus 3 raised to the power 4 multiplied by x plus 2, okay, and this itself can be written as ln that's the 5th root of x minus 3 raised to power 4 then multiplied by x plus 2. All right, so the correct option to this question is what? Option A. So here in this question we are asked to evaluate the integral. So here we have the integral from 0 to 1 of the square root of 3x minus 1 dx. Okay, so here we say let our u be equal to 3x minus 1. That means our dx, that's 3dx. That means our dx itself is what? Du over 3. Okay, so that means we need to change our limit of integration from x to what? To u. So we are going from 0 to 1. So when x is 0, u will be what? U will be minus 1. And when x is 1, u is what? U is 2. So that means that here we have the integral from 0 to 1 of the square root of 3x minus 1 dx to be equals to the integral from minus 1 to 2 of square root of what? U du over 3. So we can bring that 1 over 3 out here. So that means we have 1 over 3. Then if you integrate square root of u, of course, we are going to have this to be, this is u raised to power 1 over 2. If you add 1 to it, you have 3 over 2. Then that means if you take the inverse, that means you have 2 over 3 u raised to power 3 over 2. Okay, so that means we need to substitute the lower limit minus 1 and the upper limit 1. Here we are going to have this to be 2 over 9. Then lower limit here is 2. Then 2 raised to the power of 3 over 2 will give us 2 root 2. Then here we have minus 1 raised to power 3 over 2, which will give us what? Minus 1 raised to power 3 over 2. It's still the same thing as square root of minus 1 raised to power 3. It's like you are saying your complex number I raised to power 3, which will give us minus I. Okay, but because we are taking it with the lower limit, that means you have this to be what? Plus I. So this is the correct answer to this question, but it seems that our answer is not part of the option, so we choose option E. Okay, so we choose option E. In this question, they said find two positive numbers whose sum is 100 and the product is maximum. All right, so they said find two numbers. So let the two numbers be x two numbers be x and what? And on y. Okay, so they said the sum is 100, so that means we have x plus y to be 100. So if we make y the subject of formula, that means our y is going to be 100 minus x. All right. So also they said the product is maximum. So let's find the product. The product will be what? Let's call the product p to be xy. All right. So which can still be written as x open brackets 100 minus x. Okay, that is if we substitute the value of our x inside, our y inside. That means we have 100 minus x. So which is written as what? 100x minus x squared. Okay, so if I take the derivative of p with respect to x, that means I'm going to have this to be 100 minus 2x. All right, and if I take the second derivative, I'm going to have this to be what? Minus 2, which is less than 0. That means it is what? Maximum. All right, now if I set my dp dx to 0, that means that I'm going to have 100 minus 2x to be equal to 0. That means my what? My x is just 50. So this is like the maximum. This is like the maximum x value. All right, so for us to find the other number, that means our y is going to be 100 minus 50, which is what? 50. So the numbers are what? 50 and 50. So the correct option to this question is what? Option A. So question 9 said obtain the second derivative of y with respect to x of the function this at x equals to 1. Now here you have our y to be equals to 2x raised to the power of 2 over 5 minus 4x raised to the power 1 over 3. So what is my dy dx? My dy dx is just simply 2 multiplied by 2 over 5 multiplied by x raised to the power 2 over 5 minus 1, then minus 4 multiplied by 1 over 3 multiplied by x raised to the power 1 over 3 minus 1. Then the second derivative is just what? 2 multiplied by 2 over 5, okay, multiplied by, now 2 over 5 minus 1 would give us 2 over 5 minus 1, 2 over 5 minus 1. I know somebody will be thinking that that's like a simple calculation, but notwithstanding, I like to always cross check my answer with calculator because I don't want to make a simple mistake. So here I have this to be minus 2 over, again, so here we have minus 3 over 5. Okay, here we have minus 3 over 5. Okay, so let me write it out well. Minus 3 over 5, then multiplied by x raised to the power of 2 over 5 minus 1, then minus 1. Okay, then minus 4 over 3 multiplied by, this should give us minus 2 over 3. Yes, minus 2 over 3. If you don't believe me, let's confirm it with a calculator. 1 over 3 minus 1. That's minus 2 over 3. All right, so minus 2 over 3, then x raised to the power of 1 over 3 minus 1 minus 1. Since they said at point x equals 1, so the 2y over the x squared at point x equals 1, you know that x 1 raised to the power of any number will always give me 1. 1 raised to any number will always give me 1. So this goes to 1, this goes towards 1. I get what I'm saying. Then we have this to be 4 times 8, 4 times 3, that's 12, that's minus 12 over 25. Then here we have this to be plus 8 over 9. And if we should simplify this with our calculator, so that means we have 8 over 9 minus 12 over 25. So we have this to be 92 over 225. 92 over 225. So the correct answer or the correct option to this question is what? Option D. Option D. Alright, so let's move on to the next question. In this question, they said for what value of mu is the function f of x equals to, here we have sine, it's sine 5x over 2x if x is not equal to 0, and it's mu if x is equal to what? 0. Is continuous at x equals 5. Now in the previous video, okay, I took my time to explain what we understand by continuity at a point. Alright, but here I will just solve this question directly. For you to have a better explanation of continuity at a point, you can check out some other videos on that. You can check out Khan Academy videos or the organic chemistry tutor videos. So those guys really explain that, so you can check that out for better understanding. But in our case here, we just want to apply the principle here to find the value of our mu. So let's just go straight to the question. Now, for a function to be continuous at a point, alright, that means that the left continuity, okay, at point x equals 0, sorry, the right continuity of my function must be the same thing as my left continuity. That is, it must be continuous from the left. If the left continuity and the right continuity are the same, and the value is also the same thing as when it is at 0, then that means the function is continuous at what? It's continuous at 0. Now let's calculate our left continuity. The limit at which x is continuous from the right, this is from the right, because if this is 0 from the right, if it is approaching it from the right, that will be 0 plus. If it is approaching it from the left, that will be 0 minus. Okay, this just denotes that it's continuous from the, it's approaching 0 from the left. This means it's approaching 0 from the what? From the right. This is like, let's say you can have this to be maybe 0.001, 0.002, and why this place, you can have something like minus 0.001, like that. So that is like left and right limit. So from the right, so here we have this to be the limit at which x tends to 0. Since here they gave us the condition that x is not equal to 0. So if x is not equal to 0, that means x is greater than 0, or x is what? Is less than 0. Alright, so none of them is true. So we can actually use this function to denote our left and right continuity. We can use this function when we are using the left continuity at the same time the right continuity. So we have this to be the limit at which x tends to 0 of sine 5x over 2x, and which every one of us can easily do this, right? Because here we have the limit at which x tends to 0 of sine 5x over 5x. So that means I need to multiply this by 5 and I retain this 2. This 2 is this 2. Since I want to have like the same arguments here, I'm having 5x here, I also want to have 5x here. So that means I need to multiply the denominator also by what? The numerator also by 5. So 5 will cancel out, then I will still come back to my original question. The main argument is that I want to have the limit at which x tends to 0 of sine x over x. That is, the argument here must be the same thing as the argument here. Alright, not necessarily that I must have the same argument here, but since I have like x tending to 0, the thing is that the argument here must be the same thing as the argument. If I'm having x raised to power 5, I must also have x raised to power 5 here. So that's just that. Now, if x is tending to 0, you know that this will tend to 1, which will give me 5 over 2. And the limit at which x tends to 0 from the left of my f of x is what? The limit at which x tends to 0 of sine 5x over 2x, which will still give us what? 5 over 2. Okay. Now, lastly, what is our f of 0? Our f of 0 from the question is what? Is just mu. Alright, so and from the condition for continuity, all this must be equal. So that means I have my mu to be what? 5 over 2. So that means my correct option here is what? Option C. Yeah, my correct option here is option C. So let's just move on to the next question. In this question, they said find the non-positive point on the curve y equals to 12x minus x cubed at which the slope is 0. Okay, so they ask us to find a non-positive point, that's the negative point at which the slope is 0. So here we have our y to be equal to 12x minus x cubed. Then if you differentiate y with respect to x, that means you have this to be 12 minus 3x squared. Then if you set this to be 0, that means that we are going to have this to be 4 minus x squared to be equal to 0. That means our x is what? 2 and minus 2. But we are interested in the non-positive points. That means x is what? Negative 2. Alright, so if we substitute x to be negative 2 in this function, so that means that my y is just going to be what? 12 minus 2, then this is minus 2 raised to power 3. That means we have minus 24 plus 8, which will give us minus 16. So the non-positive point is what? Minus 2 comma minus 16. So the correct option to this question is what? Option B. Alright, so let's move on to the next question. In this question, they ask us to obtain the derivative of the function rho of x to be equal to x multiplied by e raised to power ln of x plus 1 or divided by x squared plus 1. Now, you will notice that e raised to the power of ln x plus 1 over x itself is what? X plus 1 over x. Alright, so meaning that rho of x can be reduced to what? X multiplied by x plus 1 over x, which is still the same thing as what? X squared plus 1. Then here we have this to be x squared plus 1, then divided by x squared plus 1. Of course, this will give us what? This will give us 1. So that means we have rho of x to be equal to 1. And now if you take the derivative of rho of x, this will always give us 0. So the answer to this question is not part of our option. So that means we choose option E. Next question. In this question, they ask us to find the derivative of sine x squared. DDX of sine x squared. By chain rule, you know that this is dx of x squared multiplied by d x squared of sine x squared. It's just like making our x squared our u. Now here we are going to have this to be 2x multiplied by, if you differentiate sine x, that means we are going to have this to be cos x with respect to x squared. That means we have this to be cos x squared. That means we are going to have 2x cos x squared multiplied by 2x. So that this will be our final answer. That means the correct answer, so the correct option to this question is what? Option D. So let's move on to the next question. In this question, they ask us to differentiate. Let's say we have our y to be equal to e raised to power 2x ln 1 plus 2x squared with respect to x. Now, here we are going to use our product rule. Okay, so that means if we apply our product rule, that means the y dx will just be what? E raised to power 2x, then multiplied by the dx of ln 1 plus 2x squared, then plus ln 1 plus 2x squared multiplied by d dx of e raised to power 2x. Okay, so that means here we have this to be e raised to power 2x multiplied by, if you differentiate ln 1 plus 2x squared, that means we are going to have this to be differentiate 2x squared, that means we have this to be 4x divided by 1 plus 2x squared. Okay, then plus, if you differentiate e raised to power 2x, definitely we have this to be 2 e raised to power 2x, then multiply by ln 1 plus 2x all 1 plus 2x squared. And here, if you factorize 2 e raised to power 2x outside, that means we'll be left with what? 2x inside over 1 plus 2x squared, then plus ln 1 plus 2x squared. Okay, so the correct answer to this the correct option to this question is what? Option D. Option D. So next question. In this question, they say given that y is equals to cos 2 theta, where your x is what? Where your x is sine theta. Okay, so they ask us to find the y dx in terms of theta. So here we are given y to be what? Cos 2 theta, and we are given x to be sine theta. Now my dy dx is simply dy d theta multiplied by d theta dx. Alright, so which can still be written as dy d theta multiplied by 1 over dx d theta. Now what is our dy d theta? That is, if you differentiate y with respect to theta, that means we are going to have this to be what? Minus 2 sine 2 theta. Okay, then here if you differentiate x with respect to theta, that means we are going to have this to be cos. So here we have this to be cos theta. Okay, and itself, if you expand sine 2 theta, we are going to have this to be 2 sine theta cos theta, then divided by cos theta. So this will cancel out this. That means I'm going to have this to be what? Minus 4 sine theta. Minus 4 sine theta. So that means the correct option to this question is what? Option A. So next question. In this question, they said we should evaluate the integral of sec cosec x dx. Now this is actually a standard integral, and the correct option to this question is what? Option A. Okay, this is actually a standard integral. The integral of cosec x dx. Cosec x dx. Oh, sorry. It should be option C. Correct option should be option C. Because if you differentiate cosec x minus cot x, you will have this to be you have cosec x. Alright, this is actually a standard integral. I don't need to waste much time on this. So if you have cosec x dx, the integral of this will give us ln cosec x minus cot x, and you can confirm that from any standard integral table. So the correct option to this question is what? Option C. In this question, we are asked to evaluate the integral of minus dx over x square root of x squared minus a squared. This is also a standard integral, and the correct option here is what? Option B. Okay, the integral of minus dx over x square root of x squared minus a squared is 1 over a. So like I said, this is a standard integral, so you have 1 over a multiplied by arc cosec of what? X over a. Alright, so let's move on to the next question. In this question, they ask us to evaluate the integral. This is also a standard integral. The integral of sec x dx would give us ln of sec x plus tan x. This is also a standard integral, so the correct option here is what? Option B. Then question 10, we are asked to obtain the integral of e raised to power x over 4 plus e raised to power x then raised to power 3 dx. Here I can write this as what? 4 plus e raised to the power of x minus 3 then multiply by e raised to power x dx. Now you recall again that anytime you have the integral of a function, let's say you have the integral of a function f of x raised to the power of integer n, alright, that is not 1, multiplied by, let's say your n is not 1, multiplied by the derivative of that function, alright, with respect to x, we are going to have this to be f of x raised to the power of n plus 1 over n plus 1. Now here, what do you notice here? You notice that if I differentiate 4 plus e raised to power x, I will have this to be what? E raised to power x, right? So that means my answer is just what? 4 plus e raised to power x, everything raised to power minus 3 plus 1 over minus 3 plus 1, which will give us what? Minus 1 over 2 open brackets 4 plus e raised to power x, then everything raised to power 2, because this will be minus 2, so that means this will just be 2. So that means the correct answer to this question is what? Option. The correct option here is option B. So then the question 40, they ask us to evaluate the integral of this function. Again, you have the integral of e raised to the power of negative x sine e raised to the power negative x dx. Now you observe that if I differentiate e raised to the power of negative x, so let's say u is what? E raised to the power negative x. That means my du is what? Negative e raised to the power negative x. Okay, so that means if I try to write this integral like this, that's e raised to the power negative, sine e raised to the power negative x multiplied by negative e raised to the power negative dx. All right, this will still give us like our question back. Okay, the thing here is that my du is just minus e raised to the power negative x dx, so meaning that my integral would be, so this will give me what? E raised to the power, sorry, not e, I will have this to be sine u multiplied by negative sine u. All right, negative can come out, then so what is my, this is just my du, this is just my du from here, everything like this is my du. And if you should integrate sine u, you know that we have negative cos u, that means this will give us cos u, and which is still the same as cos e raised to the power negative x. So that means the correct answer to this question is E. So that means our answer is not part of the option above, so that means the answer is what? The answer is cos e raised to the power negative x. So let's just move on to the next question. In this question, they said if y is equals to cos x raised to the power of sine x, find the y dx. So here we are given y to be equals to cos x raised to the power of sine x. Okay, so if I take the ln of both sides, so that means that if I take the ln of both sides, that means I have ln y to be equals to ln cos x raised to the power of sine x, which is still the same thing as what? Sine x multiplied by ln of cos x. Okay, so if I differentiate both sides with respect to x, that means I'm going to have this to be 1 over y, the y dx from your implicit differentiation to be equals to d dx of sine x multiplied by ln of cos x. So here I need to apply my product rule here because I'm differentiating both sides, and that means that I'm going to have this to be ln of cos x, ln cos x multiplied by differentiate sine x, that means you have this to be cos x, then plus sine x, then differentiate ln cos x, that means I'm going to have this to be differentiate cos, that means you have this to be minus sine x over cos x. That means if you simplify it, that means I'm going to have this to be ln cos x raised to the power of cos x, then plus or minus cos times plus times minus will give us minus, then sine square x over cos x. So that is our 1 over y dy dx. and our dy dx would be what? Y, which is still cos x multiplied by cos x raised to the power of sine x, then multiplied by ln cos x raised to the power of cos x minus sine square x over cos x. So the correct question, the answer to this question, the answer we had is not part of the question, it's not part of the option above, so the correct option here is what? Option E. Okay, so let's move on to the next question. In this question, we are asked to obtain the integral of e raised to the power of x plus e raised to the power negative x over e raised to the power x minus e raised to the power negative x dx. Now you should observe something, that if you have the integral of the derivative of a function over the function, alright, so here you're just going to have the ln of your function. Here you notice that I have the derivative of e raised to the power x minus e raised to the power negative x over e raised to the power x minus e raised to the power negative x dx. That is, if you differentiate this function here, if you differentiate this denominator, you are going to have the numerator. So that means my answer is just the ln of my denominator. So that means the correct answer, the correct option to this question is what? Option B. So let's move on to the next question. In this question, said if y is equals to x raised to the power 3x, so we have to find the y dx. Again, we are given y to be equals to x raised to the power 3x. So if we take the ln of both sides, that means that we are going to have ln y to be equals to 3x multiplied by ln x. And if we differentiate both sides with respect to x, that means we are going to have 1 over y dy dx to be equals to, using product rule here, that means here we have 3x multiplied by 1 over x plus ln x multiplied by 3 using product rule. So that means our dy dx is going to be what? 3 plus 3 ln x multiplied by x raised to the power 3x, which is still the same thing as 3x raised to the power 3x multiplied by 1 plus ln x, 1 plus ln x. So that means the correct answer, the correct option to this question is what? D. In this question, we have to obtain the derivative of y at point x equals 0. So here we are given y to be equals to 3 plus 2x minus x squared over square root of 1 plus x. So that means my dy dx is going to be what? The denominator, that's 1 plus x multiplied by the derivative of the numerator. So if you differentiate this, you are going to have this to be 2 minus 2x minus, that's 2x minus x squared multiplied by the derivative of the denominator. And if you differentiate this, you are going to have this to be 1 over 2 square root of 1 plus x, then over, that's not straight, over, now what you have at the denominator here is just all square. That means we have this to be 1 plus x all square, which is still 1 plus x. Then at point x equals 0, so if you substitute x to be 0 here, that means you have this to be 1 multiplied by 2 minus 3 over 2. Okay, so because this one, if x is 0 here, you'll just have this to be 3 over 2, then over 1, and this will give us what? 2 minus 3 over 2, which is 0.5. So that means the correct option to this question is what? Option C. In this question, they said given the function f of x comma y to be equal to 2 cos cube square x sine y plus x cube over y square. So we have to find the partial derivative of x with respect to x twice. Okay, the second partial derivative of x. So first we need to look for the first partial derivative of x with respect to x. And what would that give us? That is, if we keep y constant, that means we are going to have this to be 4 sine x cos x. Okay, because here we have, if we differentiate cos x, we are going to have minus sine x, so that's why we are having this to be negative. Then multiply by sine y plus 3x square over y square, which is still the same thing as minus 2 sine 2x sine y plus 3x raised to power 2 over y square. And again, if you differentiate it partially with respect to s again, that means we are going to have this to be what? Minus 4 cos 2x sine y plus 3x square over y square. Sorry, if you differentiate this partially with respect to x, that means you should have this to be 6x over y square. So that means our correct option is what? Option B. In this question, they said find the y dx. So we are given y to be x over cos x. So what to be our dy dx? Using quotient rule, that means our dy dx would be what? Cos x, differentiate x, you have 1, minus x, differentiate cos, you have what? Minus sine x, then all divided by what? Cos square x. So that means you have this to be cos x plus x sine x over cos square x. So that means the correct option to this question is what? Option C. In this question, we have to, they say given the function f of x comma y to be this, so we have to find f of y. Alright, so first thing is that we need to find f, partial derivative of f with respect to y. And if we do that, that is keeping x as constant, that means we are going to have this to be 2 cos square x cos y minus, here we have this to be y raised to the power minus 2, that means we are going to have this to be minus 2 x cube over y, then subtract 1, that means we have minus y cube. Then the second partial derivative, that means if you differentiate, that means you have this to be minus 2 cos square x sine y, because if you differentiate cos y partially with respect to y, you are going to have minus sine y. And this, you are going to have this to be, this is y raised to power minus 3, multiply, that means you have this to be plus 3 times 2 give us 6, then x raised to power 3 over subtract 1, you have y raised to the power of 4. So that means the correct answer to this question is what? Option D. In this question, we have to obtain the integral of square root of tan x over sine x multiplied by cos x dx. Okay, so let's say our u is tan x. That means using our triangle, since we are using like a trigonometric substitution, that means we need to invoke our triangle. So that means, let's say this is our x, right? So that means we have tan x to be opposite over adjacent. That means we have this to be opposite over adjacent. That means our hypotenuse using Pythagoras theorem would be what? U square plus 1. Alright, so now that means this integral can be transformed to the square root of u over. Now before that, let's try to differentiate now what to be our x. Our x just what arctan of u, and that means that our dx would be what 1 over 1 plus u square du. Alright, so that means here the integral of square root of tan x over sine x cos x dx can be transformed to the integral of square root of u over sine x. So sine x here is what? Opposite over hypotenuse. That's 1 over square root of u square plus 1. Okay, then multiply by what is our cos x? That's adjacent. This is opposite over hypotenuse. This should be u over square root of x square plus 1. Then cos x will be 1 over square root of u square plus 1. And then multiply by dx, which was our dx. Our dx is what? 1 over 1 plus u square, then du. Alright, so meaning that here, if you should look closely, you will discover that this will cancel out this. Then I'm going to have the integral of square root of u over 2 du, which is still the same thing as the integral of u raised to the power of minus 1 over 2 du, and this will give us u raised to the power of 1 over 2 over 1 over 2, which is like 2 root u. Alright, so which is still the same thing as 2. So what's our u? Our u is just tan x. Our u is tan x. So the correct answer to this question is 2 root tan x, which is our option C. Penultimate question. Here they said y is what? 1 over 5x. So they asked us to use the first principle to find delta y over delta x. That's pretty much simple. Increase y, you have y plus delta y. Then increase x also, you have x plus delta x. Then bring y to the other side. That means my delta y is going to be 1 over 5x plus 5 delta x minus 1 over 5x. And what's the LCM? The LCM is just x open brackets x plus delta x. Alright, so that means if you divide this with this, that means we are going to have this to be 5x. Of course, I can still write this as 5 open brackets x plus delta x. Okay, so that means this divided by this. Oh, I need to include 5 here also. Okay, so that means this divided by this would give me just x, then minus this will give me x minus delta x, and that is what? Minus delta x over 5x into x plus delta x. And now this is my delta y, and they asked me to look for delta y over delta x. That means this will be what? Minus 1 over 5x open bracket x plus delta x. So now the correct option to this question is what? Option A. And our final question for this question bank is this question 50. It said given the function y to be equals to sine x, they ask us to find delta y. Again, if you increase your y and here you increase your x, alright, bring y to the other side. That means we have delta y to be equals to sine x plus delta x minus sine x. Now you recall that if you have sine A minus sine B from your elementary days in trigonometry, here this is going to give you what? 2 cos A plus B over 2, then multiply by sine A minus B over 2. Alright, so you need to have all the things at your fingertips. So that means that here you are going to have this to be. So if I should call this my A and call this my B, so that means my delta y is going to be what? 2 cos x plus delta x plus x over 2, then sine x plus delta x minus x over 2, and this will give us 2 cos x plus x will give us 2x, then divide it by 2. That means you have this to be ordinary x, then plus delta x over 2, then sine delta x over 2. Since we know that x minus x is 0, so I'll be left with delta x over 2. So this is my delta y. So now the correct option to this question is what option? Option A. Alright, thank you very much for taking your time to watch this video. I hope you enjoyed this video. If you enjoyed this video, make sure you click on the like button, and also if you are not subscribed, make sure you subscribe to this channel, and also don't forget to press the notification button so that anytime I upload a new video like this, you'll be notified. You'll be the first person to get the notification. Alright, so what should you watch out for in the next series, in this calculus series? You should watch out for all the problems from your textbook, like the question bank at the back of the textbook. All those questions, we are going to solve them together, everything together. We're going to solve everything together, and I'm sure that if you can practice those questions, that is the questions at the back of your textbook, I'm sure that calculus should just be like a free A course for you guys. I wish you the best of luck. Thank you very much. God bless you.
Well, we've come to the end of today's tutorial questions. If you have any question, any comment, any suggestion you want us to know, you can put them in the comment section box below. And also don't forget to click on the like button so that more people can get to know about this. And together let us defeat this academic failure. Thank you.